Hello everyone. So today we are going to do Leetcode daily challenge. Flatten binary tree to linked list. So basically in this question, before starting, let us first see about the question. That how what does it trees do and so on. So here's the question. Now in this question we are given with the tree root, right? So given the root of a binary tree, flatten the tree into a linked list. We are required to convert this tree to a linked list. That is the question. So the thing is, the linked list should use the same tree node class where the right child pointer points to the next node in the list and the left child pointer is always null. So this is a thing which we are required to keep in mind. And then the thing is, the linked list should be in the same order as the pre-order traversal of the binary tree. So what is all about pre-order traversal? The pre-order traversal is like so the pre-order traversal is first we are having the root and then we are having the left and then we are having the right. So this is how a pre-order traversal is like, right? So in according to this scenario only, 1 minute. Actually, the thing is, this is writing in some other manner. I just need to make it just one screen. Okay. Yeah. Now it would write in better manner. So let us start. So now the thing is, for the pre-order traversal of this tree, if we check for the pre-order traversal of this particular portion, then in that scenario, how it would be like. So for that thing, basically for this particular portion, how we the pre-order traversal would be, it would be something like this, right? So for this whole particular tree, how the pre-order traversal would be, it would be something like that. This particular 2, 3, 4, this particular 2, 3, 4, this 4 will be pointing to 5, right? Then only it will become the pre-order traversal. Because in pre-order traversal, first there is root, then there is left, and then there is right? So that's the thing we are required to implement here. So the new tree would be something like this. Basically, this is now not a tree, this is now a linked list. In this Leetcode function only, they have internally have some function which will convert this tree node to a linked list, but that is basically that tree node is having a left and then right? But the linked list is only having the next pointer. So in all that context only, it would be converted internally into a linked list, but we are just required to return a tree node only. That's the thing. Means that's what I want to say. So now here the thing is that we are just required to do this thing only. Means we need to divide this particular tree into small portions. Like left subtree should be converted into the pre-ordered traversal version of itself, and then that pre-ordered traversal version need to be inculcated in the right subtree, and that right subtree need to be converted into the pre-ordered traversal version of this whole tree. So this is how we are required to think in this question, as per this question. So now comes the next part, that what are the constraints and so on. So we need to think about that thing also. So here comes the part of the constraint. The number of nodes in the tree is in the range 0 to 2000. Okay. So pretty much lower nodes are there. So we can easily go for any n square or something like that solution. Now comes the part of what the value should be. So value is somehow minus 100 to 100. So that's why we can we are like for time being we don't need to consider about the values, because it would be just converting of the tree node to a linked list, right? So that's why we don't need to consider those values also. So now comes the next part, that can you flatten the tree in place with order of 1 extra space. we want to just say that without using any extra space, we just need to convert this into a linked list. So in our brute force solution, how we would be thinking is that we need to store the pre-order traversal of a left subtree, and then we are required to use that pre-order traversal of the left subtree and then put that into the right subtree. This is the thing we would be thinking. Then we would be required to do in brute force manner. But here we can also do this particular thing in that manner that we are not required to use any extra space. So this is the thing we would be doing here. Now, before coding the solution, let me show you that how we are required to think in the boat. That would be better, I guess. So here, the thing is that we are given with this particular tree. Okay, now cursor is also visible. That is a good thing. So here we are given with this tree, right? So now here what we are required to do, I've already told you that this tree would be, now the first step would be that we would be going towards the depth of the tree in the left side, right? And then we will check. Now we have reached this left leaf node. So we are required to return a tail pointer from this particular tree to the right child of our node. That is the thing we would be doing here. So it will be included between 2 and 4. So now our new left subtree would be something like this. Now in this scenario, what we are required to do is, we are required to simply return a tail pointer for this 4 to our 5. That is the thing which we would be doing here, and it will be embedded here. So because the pre-order traversal of this particular portion is this, right? So next we will be converting this particular tree into something like this, and okay. So we need to return tail of linked list to the right child of the node. This is the thing which I was earlier also saying. So this is what we are required to do here. Now comes the next part, that how we would be doing. Is in the process of doing all this, we would be directly making our left subtree towards the right subtree, right? And all the left portion would be directly turned to null. And this is how we are required to return this particular linked list. Now, this is pretty much idea of how we would be making this particular linked list. And in all this scenario, what we are required to do is that we are just traversing, doing it in all recursive manners. That's why we would be using a recursive stack. That would be the space which we are using, but that is internal, right? So that's why we can say that if we consider a space of recursive stack, then it is order of n solution, else it is order of 1 solution in context of space complexity, but the overall time complexity is order of n, and here order of n is the worst case scenario, because the time complexity here is simply the height of the tree. So the tree could be a skew tree also. Means a tree could be like this itself. The cursor hand, that's not good. So the tree, I don't know why cursor hands. So the tree could be something like this also as the input. So this is the skew tree, right? So in this scenario, the time complexity would be order of n, but in the average case scenario, the time complexity would be order of h, basically the height of the tree. So that's the reason we are taking the worst case time complexity, that is order of n itself. So that's why we are taking here the time complexity as order of n, and the space complexity is order of n for that fact that we are using recursion here, and recursion is internally using a recursive stack. So this is the thing for the time complexity and the space complexity part. Now comes the part of coding this particular solution. So for the code portion, let me show you how we are required to code here. Now the function which was given to us, it is returning nothing, right? It is a void. So we have built a new function, that is Flatten tree function, and in which we are passing the parameters as root, right? Basically we are passing this tree node in this particular flattened tree, and this particular will return the required linked list. In this, what we are doing is we are simply making this function which will be returning a tree node, right? So if a node is basically null, means while traversing that whole tree, if it reaches the null node that we can reach in this scenario, when when we will be reaching this particular leaf node, so it would be having null here, it will be having null here, right? So when it will be checking for its left node, then it is null, but when it would be checking for its right node, then it is also null. So in the case of backtracking portion, then our this particular function, it will be having null in the case when there is the right side call. So that's why in that scenario we are required to handle that null scenario. So that's why if node is null, then we will be returning the null pointer. So for a leaf node, right, means for this particular tree only. So for this tree, both of the left and right are null, right? So in this scenario we will be returning directly the node, and then tree node style left, basically tree node left tail. Here we are keeping the track of the tails which we are required to return to point towards our right subtree, right? So that's why here we will be calculating a left subtree, here we will be calculating for a right subtree. We are required to do all the calculation in our left subtree. So how we would be doing a left side calculation? The way earlier I had told you that we are required to do basically this particular tree need to be captured here, this 2 bond need to be broken, and this 2 bond need to be made here, so that it could be like this 2 3 4, right? So that's why in that scenario only, what we are doing is we are checking that if left tail is not null, right, then we are doing that left tail right portion equals to nodes right. So our left tail would be 3. If we check for this particular portion, our left tail would, because what we are required to do is we just need to put our left tail which is there. Left tail basically this 3. Yeah, left tail basically this 3. That is required to be pointing to this right portion of the nodes right, and the nodes right equals to node left. So yeah, when it would be pointing towards this portion, right? So at that scenario, we would be like facing at this particular portion, and then we would be making this. That's the thing here. Then 2 is basically our left tail, then 2 need to be followed there. When 2 is here as the left tail, then that tail need to be returned to 5. So in that scenario, the thing would be something different. This was the this what I was explaining was for the 3, when 3 is as the left tail, not the 2. Because when 2 is there, then pre-order traversal would be already there, and in that scenario, we are directly embedded into the 1 then 5 portion. So now comes the last portion, that is we are required to return right tail when we are required to return this right tail, and in this right tail the value should be something like this, that if the right tail is null, basically we don't have any right portion, means when it would be pointing towards this portion, right? Then in that scenario we are required to return the left tail, else we would be returning the right tail itself, basically whatsoever value would be there in the right tail. That is the thing which we would be doing here. So this is how we are required to do this question. If you have any doubt about this question, you could comment, and please do like and subscribe to my channel. Thank you.